Welcome to the Explainer. So, let's talk about a huge problem. One that every single city on the planet has to deal with. Garbage. What do you do with it all? It's this crazy battle between these futuristic technologies and just mind-boggling costs. We're going to dig in and figure out what it actually takes to turn all that trash into treasure. All right, to really wrap our heads around the sheer scale of this, let's take a look at one city. We'll use Quito as our case study. Get this. Every single day, the city generates 2,200 tons of trash. Can you even picture that? That's like 1,000 pickup trucks worth of garbage every single day, just piling up.
So where do you even start with a problem that massive? Well, here's how we're going to break it down. First, we'll look at what's actually in that mountain of trash. Then we'll compare two totally different game plans for dealing with it. After that, we're diving into the pretty wild technology involved. We'll follow the money to see the jaw-dropping price tag. And finally, we'll pinpoint the 3 things that can make or break a project like this.
Okay, first things first. To solve the problem, you have to understand it. So what exactly are we looking at inside this daily mountain of garbage? Knowing the ingredients is everything.
Okay, so when you first look at this, you might think, well, over half of it is just organic stuff. And you're right. But for a waste-to-energy project, the real gold is in those other slices. See that? The 10.6% plastic and the 10.2% paper and cardboard? That's not just junk. In this game, that's high-octane fuel. It's pure, concentrated energy just sitting there, waiting for someone to unlock it.
So with this kind of trash profile, how do you move forward?
Well, you get 2 very different schools of thought. And you can see it play out perfectly when you put the city's own public study side by side with a private company's investor pitch.
And this just lays it all out perfectly, doesn't it? It shows you the 2 completely different mindsets. On one hand, you've got the city doing its homework, right? A super cautious, analytical study weighing all the pros and cons of every little piece of tech. Then, on the other hand, you have RIVER ESP, the private company, coming in hot with this really confident, super optimistic sales pitch for their one-and-done, patented solution. Now, what's interesting is that even though they have different approaches, they're both circling around this really advanced tech called gasification. So what is it? How does it actually work? Let's get into it.
So listen, the most important thing to get here is that this is not your old-school incinerator. We are not just burning trash. No, gasification is way more sophisticated. It's a chemical process, really. It uses insane amounts of heat to basically transform waste into a useful fuel called syngas. And what's left over isn't toxic ash, it's this stable, almost glass-like material.
And when I say insane heat, I mean it. Check out this quote from the city's study on one type, plasma gasification. It says the temperatures are over 14,000 degrees Celsius. That is literally hotter than the surface of the sun. We are talking about an incredible amount of energy. So how do you take all that complex science and, package it up so you can sell it? Well, a company like RIVER ESP presents it like this, as a really clean 4-step system. First, you sort the trash, right? Get the perfect fuel mix. Then, into the special patented reactor it goes. After that, you've got this syngas, but it needs to be cleaned up and cracked to make it super pure. And then bam! The final step. You use that gas to make electricity. See? It's pitched as this perfect, elegant, turnkey solution.
But, and this is a big but, tech like this does not come cheap. Not even a little bit. So what are we talking about in terms of actual cost? Let's follow the money and look at the numbers from both the public and the private side.
Okay, so the city's own numbers are pretty eye-opening. They show that plasma gasification is by far the most expensive option. We're talking $123 to $149 for every single ton of trash. Compare that to something like anaerobic digestion, which could be as low as $18 a ton. It's a massive difference.
And when you scale that up, the city is basically preparing for a $200 to $300 million investment. That is a gigantic amount of money for any city to have to find.
So if the city is planning for, let's say, $300 million, what happens when the private sector comes in with their pitch? Well, the story gets bigger, and that price tag, it gets a lot bigger.
Yeah, you're seeing that right. According to their pitch deck to investors, the price for their complete German-engineered system is almost €500 million. That's way higher than the city's own math, even if you account for some differences in what's included.
So why on earth would an investor put up that kind of cash? Well, for this number right here. The company is promising an 18% internal rate of return. That's the kind of shiny, attractive number you dangle in front of financiers to get them to write a very, very big check for a high-risk but potentially high-reward project.
So you've got these massive costs. You've got these wildly different financial outlooks. With stakes this high, what does it actually take for one of these things to work in the real world?
So what's the difference? What separates a groundbreaking project from just a really expensive failure? Well, according to the city's own deep dive, it all comes down to 3 things. And these are critical. It doesn't matter who's paying. First, you've got to have the right rules and a solid government framework. You just can't start without it. Second, you need some seriously creative ways to fund it, probably a mix of public and private cash. But here's the big one, the most important one. You need everyone to stick with it for the long haul. You need politicians who won't cave when things get tough, and you need citizens who are actually bought into the whole vision. If you don't have all 3 of those, honestly, even the most amazing tech in the world is probably going to end up as a pile of scrap.
And that really brings us to the final billion-dollar question. Is this kind of next-level waste-to-energy tech the future, the key to sustainable cities, turning our biggest problem into an actual asset? Or is it a fantastically expensive gamble that cities and their investors just can't afford to take? The answer? Well, it's still being written, city by city.